live. Uh-huh. Reflect. Hi guys, how are you? I hope you are well. Just a moment. There you go. Anyway, guys, how are you? I hope you are well. Welcome into another live session, building LLM from scratch. So we are going to build an LLM from scratch. We are going to continue from last Sunday. Yeah, we did some on Sunday. So today, here we go. Here we go. We are ready for this. We are ready for this. You can invite your friends to join the session. You can also like. You can also like. And anyway, you can get the also you can get the live the code that you can get it in the description below. Yeah, it's right there. You can you can get it in the description of this video. Anyway, where are you watching from? I hope you are well. You can just say hi on the chat so that we can say hi on the chat. Feel free to say hi on the chat. Feel free to say hi. Anyway, let's get into it. Let's get into it. You can invite as many people as you want in the session. You can invite whoever you want in the session. Yeah, today we are going to do, we're just going to continue from where we left. Yeah, I hope you're well. Yeah, let's do this. Let's do this. Let's just go straight to it. Last week, that Sunday, we built some part of the. So we're just going to continue from where we left. Actually, last week we were setting up most of the. We're not going to see any interaction from the system that we are building, but to experience. We are going to continue building the architecture. Yeah, I'm going to share my screen in a few. In a moment. But there we go. Yeah, there we go. You're ready for this. We are ready for this. Absolutely ready. Who is this? Someone is called Soibu. Soibu Soibu Bilali. How are you? Where are you watching from? Anyway, let's do this. Actually, we are building a lot like GPT. We are building something like GPT. And from building that system, we are from Tanzania. Wow. From So we were just building a large language model, just like GPT, with 10. So we discovered or we discussed any process. And I'm going to share my code as but in case you want to clone whatever we are going, it's already in the description below of the video. Check out the description. You are going to get the code. You are going to get the code from the description. You are going to get the code from the description. You can clone it, the already built system. Then you can keep training the model. You can run as many times as you want. Keep training the model, on training the model. Yeah, 10 million parameters, 10 million parameters. So it's not big, it's a very small amount of parameters for test for building the architecture first of all. Then after the architecture, that's where now we are going to keep expanding with more data, more data, more data as we go. Then we are going to have a working model, yeah, 10 million parameters. So that is just the base number of parameters that we could build for prototyping. Then we work on it. Yeah, I can see my virtual environment is ready here. And here's the code. That we are working. But as soon as you want to see the process or the document that we are following, I also share this document in the code, should be somewhere in the code. So yeah, maybe to give you an architecture of how it looks like, you can check the code from GitHub. Let me see. Let me say my GitHub. You can see the file structure. You have the file structure that we already have. You can check the link in the description. You can give me a star. You can give me a star. You can as well fork. You can fork. So basically, this is the folder structure in case you are wondering. And I'm in each. So for example, we have the YouTube Live. Basically, that is the project name. Then we have the data right here. The folder that are going to contain the data. Then the model, the folder that's going to contain the model, the styling, everything. Then our configuration files, .py file, the generate that's going to be used, the logic behind generating content. Then we have the chat interface that we are going to write. For example, you need a chat interface where people can talk to or can type anything. Then we have our everything. It's already installed. And the process for cloning this code, for example, this one, you clone the virtual environment, activate it, and then you run your code. TXT. By the time that you have, make sure that you have the env active. active. Then you anything right here. You can do anything. So the code is the description on how to access the already built prototype. It's not perfect. It needs a lot of training. So no problem, no problem. So basically last time, a quick overview of what we did. We did some few models, for example, downloading the data. And the data, it's not a big amount of data. It's the Shakespeare data, Shakespeare tiny data. It's basically poems, books, something like that. Just reading data um, from poems. Then we loaded the data. You can check the previous video on how we did this. We explained every single part of the code. We prepared the data ready for training. Prepared the data ready for training. Then we create the model attention. That is the brain of the model that is going to interpret the data and everything that we needed here in the attention.py file. But today, because we have a guide, we can go create other parts of this project. Today's day 2 of building this LLM. Day 2 of building this LLM. But day 12 of me going live on YouTube from last year. So let me see the file that we are working on today. Let me see. We had a guidance, we had a document that guided us. Remember that we are designing everything from scratch. So I just show you the process of doing step by step. That's why we have this document here for guiding us. Okay, so we want to create the GPT.py file. We want now to create the GPT.py file. With this GPT.py file, we are going to explain each part of the code. We are going to write the code if need be. We need to write every bit of the code. So basically, it's inside these models. So we are going to write GPT. We're going to write the GPT.py file. So it's not a lot of code. Around, we shall see. We shall see. Remember that requirements.txt file. All these requirements that we have here. Remember that we had PyTorch, we had NumPy, we had token, TQDM, then we had request, and each has. Okay, let me see. Let me see. You guys can't hear me well. Need to adjust as well. It should be cool. Let me just adjust my microphone. Yeah, now we can go with GPT.py. First of all, we need to import. Remember that torch that used. We need to import torch. We need to import NN. Then we need uh, import torch.nn.function as file. So we are going to import everything here like files in file system. So and also as well, we are going to import. So from mod attention, we are going to explain each code worry not. Import transformer block. Transformer block. So in case you're wondering, where are we importing here? So from model, folder model. From this folder model, dot attention, we have this attention.py, that's what we are calling import. Model.attention.py, import this class called transformer block. Remember when you transformer block? It should be some here. Transformer block. Yeah, there you go. We are going to import this basically right here. We are going to import it here because we need to use it. So after importing, now we can now create things like class. Let's call it simple GPT. Simple GPT. simple GPT, then you can import m dot module dot module dot module. So right here is where we are going to write every logic that is going to now create the GPT, the wrapper, basically the wrapper. So basically, what we're trying to do, we have our own data that is not changed, like do anything. I want to create this model where you can just search, or you can just type the way you write GPT, and then it gives you solution to some. But we're going to use our own data. We're going to collect our own data, clean the data, model with that data, respond from whatever that we fit our model with. So basically, that's what we want to do. So I'm going to um, define it, a method. I'm going to define a method. I don't know my autocomplete. Autocomplete is annoying sometimes. Self. So basically, as you can see, my autocomplete is trying to predict from what complete. This is Copilot, GitHub Copilot. So I can just autocomplete and then I'm going to explain what we imported right here. What we imported right here. So we have the main method. So we are going to we are going to use or define the vocabulary size. Then we are going to embed in which we defined in the previous video what all these terms mean. Find the number of heads, the number of layers, the block size, and also the dropout z. Then also the dropout rate in which you are going to give it 0.1. But in case you're wondering what is dropout, in case this is a new word to you, so it's something called overfitting when it comes to AI. Now, when I train, um, so basically here we are trying to calculate the error rate. So our model is 100% accurate. So this is to avoid overfitting. So we give the error rate of 0.1. So basically this one stands for 10%. So we train our model to be 90% accurate to avoid being biased, to avoid giving us unnecessary solutions which we don't need or which is not correct. So basically that's what we are trying to do. So I can either decide to go with autocomplete or type. So I can check, let me just autocomplete. And then we are going to explain whatever it's doing right. So we are going to define a super method right here, in which, remember this self here, that we are going to pass right here. Self dot token embedding, uh, self dot token embedding right here. Self dot um, token embedding here, which is basically going to map the token IDs that define in our attention file. So right here, so we are going to use the the PyTorch NN module dot in which we are going to embed size and the number of embeds here. Just to explain the vocabulary size. So we have this chunk of data that we have. So we need to extract the juice from that data and can be the vocabulary size. We don't want to, whenever our model is giving out the output, over explain, and I explain, just want it to be moderate depending with the input. with the user. So we have self.position embedded, in which this is basically a variable. Embedding again, we embed the block size, and also the number of pen. So basically, it's going to basically add information from where each token is. We are going to define token the moment that now we what is tokenization. We are doing the tokenization. So self.blocks. So we have here something that we are calling self.block. So here we are going to use the sequential right here. Then we are going to use the transformer blocks that we defined, and which right here our attention to I. Then we are going to basically use it right here. You're basically going to use it right there. Then you're going to pass the number of appendings, the number of heads, the block size, pouch or void overfit. Then other, in which you are going to select the range of number of layers. So we say we are going to build um, 6 layer um, architecture of this AI, 6 blocks, 6 block AI. So after that, we are going to define self.length fine valid variable names that can understand, one can understand the length file in which you are going to use the layer no the layer normalization, in which you are going to embed the number of embedding. So in case you're wondering, why do we have all these techniques? AI it's all about it's really about these technical words, but all about mathematics, calculation, a lot of somehow short summers, science, some science kind of terms. So we are going to pass the number of heads, in which in the number of heads, here we are going to pass the number of heads, the vocabulary size. So basically this is the class or that we are going to define the GPT, in which what we want it to learn, build, and do anything else that we. So over here, we are going to calculate something that we are going to call it. Uh, is it let me check. Self dot apply the initial weight. Weight. Yep, we don't have these, but it's fine. It's fine. You are going to figure out. You are going to figure out. So we are going to define the number of parameters. In which the number of parameters is very basically simple. So we just going to calculate the number of parameters that we have. Remember, we are building a parameter model. So that's what we are going to calculate uh, these from. Basically, this we don't need this line of code, but in case you want to know the number of parameters that your GPT can hold, or the capacity of this model, you can include that line of code, or we can do away with it. We basically don't need that line. So I want us to define another block. I want us to define another block. Let's just create another function inside here. Check. Let me check in this. you can define a variable in which you are going to call it initial weight. You're going to initialize the weight here. Let me just inspect this code. If it makes any absolute sense, let me just check. If it makes any absolute sense. So if we define the initial weight, right, we define the weight. So we are going to calculate the weight, the initial weight of the model, in which of instance here. If instance.module.linear, then we use the PyTorch library dot and n init.normal. Just inspect this code. We pass the module weight. The mean, by default, it should be 0.0 before we calculate the mean. Then the standard output, that is standard deviation here. Okay, this one looks good. Looks good, looks good. Um, so basically here we are going to check the biasness of the model. If the model does not have any bias, then we can say the biasness is zero. So it's not going out of context. It's not going to give things that do not exist. For example, the air should not give us output that does not exist. Things that do not exist outside our data source, outside of the data that we have trained. That's why we need to check the biasness right here. So if there's no instance usually that we calculated the biasness, then just basically go ahead and embed the weight of the model. Basically, this one is the GPT architecture that we just want to embed weight of that particular model, the weight of that particular model. So we calculate the weight of that model. Yeah, there we go. Let me just check if this is correct. Just don't be so normal. Do dot weight into 00. Yeah, seems to be correct. So I can define another that is just the pass that is going to give it the pass, calculating the pass. Tell our model to go ahead, our model to go ahead and give us a valid output after calculating the biasness and so on. After calculating the biasness and so on. Maybe I can autocomplete and check out if this makes any absolute sense. Okay. So this one is index dot shape and embedding self dot index position self token embedding position dot blocks final head logits. So in case you're wondering this code what it's doing, remember that we don't our model to be biased. So have you seen um, what do they call benchmarks? This model benchmarks where they say, this model is better than this, and they are showing some graphs that proves um, this model is better than the other model. Or if model A is better than model B with all those graphs. So we calculate, so basically we are trying to calculate out of 100%, our model has passed all these checks, that is checking the biasness, making sure that it's not giving us false information, then checking all if all parameters meet. Then it gives us the graph. The moment that we are trying to train a model, we expect to do some benchmarks. We expect to do some benchmarks when it comes to this AI. We expect to do some benchmarks. So how do we do the benchmarks without any problem? So we define a method here, this function method here, in which we're going to use the PyTorch library, then it's going to calculate um, biasness, will give us all those kind of graphs any without any loss, any kind of any kind of loss. But this I don't think it is right. Let me check again. So BT index shape. We have the hmm, maybe you can do away with this. Let me just follow the code that we have right here. Let me just follow the code that we have. Still doing the same thing. Let me check the define method itself. Touch. Yeah, we can pass something here that target. Get to touch dot tensor. Touch dot tensor, in which we can use is equal to none, or we can use what's this symbol here, or none should be not execute to anything like. So over here we can pass this symbol. This one is going to use the tuple to play. It's going to use the tuple in a list touch dot tensor. Yeah, it should be dot tensor. Dot tensor. No, let me check. Targets touch dot tensor. Then we have the touch dot tensor, which should be equal to none or none. Can we just use either or none? This one to equal, changes to equal. Then now we can write the block of code right here now. So we can write the block of code in which, of course, you are going to pass the first. You can write any variable in case we are just to write a very complex model. We don't need to write these shaggy variable names. We don't need to use these shaggy variable names. These shaggy variable names. So we can use the t that we just assigned right here. It's less than or equal to the position of the number of embeddings. Then we can just say sequence length exceeded. Sequence length exceed block size. So that our model does not overtrain, does not overfit, does saying it does not overfit, so it can just print out. Basically, this one is print out. It's a print out. So this one should be assert set.block size. Assert. This one should be fine. It should be fine. So we can pass the token embedding. That should be self.token embedding, in which you are going to pass index right here. You are going to pass the index straight right here, in which we need position of the embedding as well. We need position of the arrange. Pass the token, the device, index.device embedding. Okay, that makes sense. Then we can pass, can just pass for random variable here, in which is going to be the token embedding plus the position of embedding. So basically, this one we are doing the benchmarking even before we produce out, even way ahead before we produce the model, way before we produce the model, way early before we produce the model. Okay, let me see what else do we need. Do we need that? We need to complete this function. SPT. Okay, let me see what else do we need. Do we need the blocks? No, sorry. Yeah. We need subject blocks. We need a subject final length, which are going to pass the x, which is the variable. We are basically trying to do the graphs. Yeah. I can define a variable called logits, self.head, in which we are going to be loss of none. Make sure that we have no loss. Make sure that first of all we have no loss. So we say we don't want any loss in our GPT. We are saying anytime that we are producing any out, first of all, we should not have any loss. We should not have any biasnesses. We had defined right here. The biasness. So it should have no loss, first of all. It should be as accurate as possible. So we can calculate the loss now. We can define a variable if target dot not is not null. If the target is not none, we can pass, we can do the loss is equals to percent. Do we use the percent v? Let me check. So to calculate the loss, TensorFlow dot percent trophy, in which we are going to use the logits size del one, start somewhere. Okay. If you have no loss, it's not none. If you have no loss, start calculating the loss that is occurring during the training and outputting of the model. What this is called. So after we calculate the loss, now we can return this. It's also the loss that we just calculated. We can return all these, the headers and also the the loss. And also, I think that's it for the simple GPT file. Is there anything that we need to do? Yeah, we have these variables and we have not called them. We need to call these variables. Okay, we need to call them. We need to call them right now. Very simple. We need to call. So, um, in this, where is the layer? It's in this layer define. So it should be also. So we can define generate. Should be the same level. Yeah. This time I'm not using auto complete. It's messing me up. We are going to pass the generate, in which is going to generate the text now. We're going to pass the self to tensor, the maximum number of new tokens. Yeah, temperature. Need to define the temperature, which is a float of 1.0. Then the top token. Ah, ah, this one is cool. We can go ahead and calculate the evo self dot eval self dot eval. So over here we can now try to loop through the number of tokens. Tokens. So for everything in range of maximum tokens, what do we need to do? Let me just cross check. Index condition IDX underscore condition index condition in which it's going to be index like this. Should be like this from now side self dot position of embedding is equals to number of embeddings. No, one is wrong. Just going to calculate the self dot block size. Mm, so block size. The block size. There you go. Now what else do I need? I need to calculate the logics. Let me confirm. Before autocomplete, we just autocomplete. I it out. Index dot condition logics self dot index of the condition logics equals to logics divided by the temperature. Then we define the top token is not one. We just write any variable name here. This one used to be everything in touch dot token logics dot mean dot top k. It's just a variable that we defined here. Logics dot size. This code doesn't look anything. Anyway, I'm also using AI to autocomplete and see how faster we can build this model. We have logit, we pass it right here. Yeah, it's closed here. Logit is all the values right here. So in case you're wondering all these kind of terms, we defined everything bit by bit in the previous session. You can just check it, the previous live recording. Find all these. We explain each part one by one. You can pass the props here. You can just write any variable. These are just variable names. I don't know what they mean here. What is with prop? Just a variable. So softmax, logic, dim, -1. The next index, it should go to multinomial, multinomial. Okay, just pass the index. Get cut. Just to index. I just want to inspect this code to make sure that it's correct. This one looks correct up to here. Then you return the index. Okay, this one looks clean. The probes, we calculated the index, we calculated the index, the next index, which was cool. Which was basically cool. I think this file is done. Let me just cross check from existing file. This one looks to be cool. Maybe we can create the next file. Let me check if it needs a lot. So we are just going to go bit by bit for this data whenever we need them. For now, we don't need. We are just preparing to make sure that everything is cool. We need to create the training model. Maybe we can create this next time. We are trying to train this. But for now, let me check where we are at when it comes to this architecture. It's going to do the tracking in performance through loss curves. So, in case you're wondering what this code is, basically, you see this or this GPT.py, this GPT.py, whatever we try to do, it's basically trying to do something of this kind. So, the moment that we are ready to train our AI, we are ready to test our AI so that it passes the benchmark, does not skip any necessary part. We want to make sure that it does not skip any necessary part of our code. It does not have any large amount of loss. And for example, loss, we mean whenever you are trying to should respond with them. It should not respond with something else. But if it responds with something close to hello, then that means it's a good model. But if it's well trained, but if it doesn't respond with anything like responding to greetings, then that means the model might be might be wrong. So first of all, that's what we're trying to do here. Creating the tracking engine that is going to track if our model is right, if our model is having some problems, or if our model is having some biasness when it comes to this process, if it's having any biasness. So this is what we are trying to basically calculate. So the next step that we are going to do is generating the text, actually token by token. Just want to generate that token by token. So when the next thing that we are going to do is basically creating the 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 code for now training is going to involve the action of training. So we train it, we train it, we train it. So this is what it should basically it should do. Whenever you ask it something, for example, word like Romeo, it should give uh, Romeo, depending with the data that we trained our model with. So that is what the action is going to be doing. So basically, we have our engine that we have already computed. So we just run the training as many times as possible. So what is training? Training, see all these algorithms that we have written. Um, Now we are going to run that code several times. The first time it's trying to learn and understand. Second time trying to learn and understand. Store that in its own context or in its own memory trained data set. Then we get the trained output. So the process of training is basically like how you train as a human being. How do you train reading, writing, and all those kind of things? It's very easy. First of all, you learn how to write sentences one by one, A to Z, A, B, C, all the way to Z. Then the next day, you forget how to write T. You forget if we have G. So what do? You start again from A, B, C, D, E. Then slowly by slowly, you start learning. This is the sequence of how you mention from each other. A, B, C, D, A, B, C, D, without forgetting. So that's what happens in the process of training, in which we created the logic for in which um, it did not train, in which we want to train model correctly. Thank you, David. Thank you, David. I'm checking. Plug in. So our AI in the next code that we are going to write, we are going to make sure that it trains sequentially. Train just like training a child. Produce hello world text. You can train it like over 10 times for it to for it to actually produce a simple thing like so this one also depends with our the CPU, the GPU, kind of GPU that we are basically using. Remember that we are just using a normal my laptop just to write this. So we all these we don't have the fast that will enable us to train more than 10 million parameters of data from Shakespeare, emulated Shakespeare, isn't it? So basically that's what we're trying to do. So in the next um, session, that's exactly what we are going to be doing. We are going to do the training, training part. We are going to use going to write the training data. So write the type of layers. For example, if we check this code out. Let me just open the one in here. But in case you want to get the data, this code, you can check it in my GitHub. It's in the description below. Let me just there you go. The file is opening. So if you check on this file where we are going to train our model from, remember this simple GPT file that we just wrote right now. This class, we're going to use the entire. Then we're going to define the configuration, the number of embeddings in which you are going to explain what we mean by this number of embeddings. We are going to learn on how many characters do we, um, how many batches do we train our data with, or our AI, number of maximum steps that we are going to use so that we don't overuse the resources, our CPU resources, and all these kind of things that we are going to define. We are going to define things like the learning rate, how fast do our AI um, learn, things like the minimum learning rate, this LR. So we are just making sure of those things like warm up steps. What is warm up steps? For it to train, all those kind of steps. That's what we are define in our next session. How we train the AI, and in our next session, we should be able to write and actually spin the code and train our model as we want, and train the model as we wish to. So basically, that's what we are going to in the next session. Okay, we are going to find, we are going to give out the output as well. And we are going to see how does change data looks like. How does change data set looks like when it comes to AI. We are going to see all that. How all that data looks like. So basically, that's what we are going to do today. For the next session, today's session was a little bit brief. It was short. It was meant to be short so that we prepare ourselves for the next session, which is going to be on Sunday, and when it's going to be a longer session as compared to the other sessions we do. Yeah, so thank you guys for joining. Thank you everyone who joined. We appreciate your time. I can't wait to see you in the next session that will be on Sunday. That will be on Sunday. Thank you for giving me 1 hour of your time and learning to. Most of these things I don't know. Most of also I don't know. I'm trying to figure out together. We are trying to figure out uh, together some of these things. Yes, I've trained several models. I've written code to train several models for business logics, and this is new. Basically, I've been working on machine learning algorithms that does not need you to output any information like the chat. So this we are building it together, figure out how it together. Yeah. Thank you guys. Have a lovely evening. I appreciate your time.